Hello and welcome to our second video on chemical reactions. In this one, we're going to explore how you write out a chemical reaction, what the terminology involved is, and how we go between the sentence form and the chemical formula form. But first, I just wanted to ask you, what kind of doctor is Dr. Pepper? I think he's a physician. Thank you. Thank you. Thank you. Thank you. Yeah. All right. Don't forget that. So, a little flashback to what we learned already, which is chemical changes. And what we said when we learned that is that a change in the chemical identity of a substance is called a chemical change. If we change the chemical identity, we literally change the numbers of atoms involved or the kinds of atoms involved, we've made a chemical change. We also said that we can see them when we're looking at what's happening. We can see things like bubbling, or a new color, or a solid appearing where it wasn't before, or even something getting hotter or colder. Those are signs that chemical changes were occurring. In chemical reactions, we're actually going to explore what happens when we get into these, when we see these chemical changes. So, just straight definitions for first, a chemical reaction. What's that? It's when atoms are rearranged so that one or more substances turns into different substances. And that's at the level of actual atoms. We're not talking about something like melting. We're talking about the atoms, the arrangement of atoms, the way they're bonded is different after than before. And the stuff that goes into a reaction, our starting stuff, is called reactants. Reactants, that's what goes into a chemical reaction. And whatever comes out, whatever different substances come out, we call those products. Products. Just like if you do multiplication in math, you have a product, right? A product is what comes out. It's the answer that comes out of a chemical reaction. If you need some more time to take that video, or to take that note, pause the video. If not, continue along. Here's an example of a chemical reaction you may have seen before. So a classic kids' science fair project is to build a volcano and then make it erupt and go, and all this bubbly stuff comes out. And if you're good, you add some food coloring, so it really looks like that lava coming out, hot lava. But what actually is going on? How do you make the frothy eruption? Well, you mix baking soda and vinegar. Baking soda and vinegar. And that's a chemical reaction. Here it is shown to you in a couple forms. These are called space-filling models, and they're just models of how these molecules are formed. We start off with vinegar. Vinegar is more formally known as acetic acid. Here's its chemical formula. And we add in some baking soda. Baking soda is sodium bicarbonate. That's its chemical name. We put those two things together. You can see what happens afterwards is that the different atoms represented by these spheres here have shifted places. And our results are this substance called sodium acetate, and we get some water, and then we get lots of carbon dioxide. And the carbon dioxide is what actually creates all the bubbles and the frothing that makes for an interesting looking eruption there. Fun fact about this, sodium acetate, this stuff is actually the flavoring used in salt and vinegar potato chips. Even though this is actually vinegar, this is the stuff that they use to flavor your salt and vinegar potato chips. So, again, using our terminology, these first two things are called the reactants. That's what goes in, and then this arrow shows us that everything's moving in this direction. The reactants then become the products, right? Here are the products. These three things are the products. All right. And so chemical reactions can be described two different ways. We can use words, or we can write what we call chemical equations. In this video, I want you to get familiar with how we do the two. So going back to our frothing example, let's do it in sentence form and in chemical equation form. So here is how we would write it out in words. In words, we could say acetic acid, that's vinegar, reacts with sodium bicarbonate, that's baking soda, to form sodium acetate, water, and carbon dioxide. So what we said were these reactants over here will react, there's our verb, to form sodium acetate, water, and carbon dioxide. Those are our products. An alternative way of writing the same thing is to say acetic acid and sodium bicarbonate yield. Sometimes we read the arrow in a reaction as yield sodium acetate, water, and carbon dioxide. Here's how we would take that and write it into a chemical equation. So acetic acid is C2H4O2. Don't expect you guys will know how to do that one in particular. So I'm just telling you. You should be able to know how to write out sodium bicarbonate, NaHCO3. And those two, because they're coming together, we put a plus between them. And then the arrow indicates that we're going from our reactants to our products. And then we've got our NaC2H3O2, that is our sodium acetate, plus we also get some water, plus we also get some carbon dioxide. So it kind of looks like an equation in math. This thing plus this thing equals this thing, and this thing, except that we use arrows. Let's look at some examples. If our sentence form says nitrogen and hydrogen, so just telling you that these are nitrogen gas and hydrogen gas, and they are found as N2 and H2. And they react to form nitrogen trihydride. So we want to take this and turn it into the chemical equation form. And so we know our reactants are nitrogen and hydrogen, N2 and H2, and then we would want to use our covalent compound naming to figure out that this is 1 nitrogen and 3 hydrogens. So we should end up with this, N2 plus H2, those are our reactants, arrow pointing to NH3. So this reaction is these two things combined, and they form nitrogen trihydride. Nitrogen trihydride. Okay, another example going the other way. We might find this chemical equation and try to write it as a sentence form. So we've got Mg plus AlCl3 yields Al plus MgCl2. And in word form, what we can say is magnesium, we just looked that up on the periodic table, that's magnesium, and aluminum chloride. So this is an ionic compound. There's a metal, there's a nonmetal, and we name it as aluminum first, or cation. And chloride, chlorine is the atom, chloride is the ion, so that's aluminum chloride. And they react to form Al by itself as aluminum plus magnesium chloride. Aluminum plus magnesium chloride. So there's two examples doing it in either direction. Here's one for you to try. So I've written out in chemical equation form Br2 plus, this is Ki, yields KBr plus I2. Pause the video, try that one in your notebook. Okay, welcome back. Let's see how we did. In sentence form, here's how I'd write it. Bromine, so Br2, that's bromine by itself, and Ki is potassium iodide, it's an ionic compound, reacts to form potassium bromide, that's another ionic compound, and iodine. I2 is iodine, as you might find it all by itself. Here's another one to go the other way. So try this one. I gave you in sentence form lithium and oxygen in its O2 form, react to form lithium oxide. Try making that one into a chemical equation. Pause the video. All right, welcome back. Let's see how we did. So lithium, we look up on the periodic table, that's Li, and we put a plus for the and. O2, we already gave you. React to form, so that's going to become our arrow, lithium oxide, and so our drop and swap is going to be needed there. So Li plus O2 yields Li2O. So lithium oxide is written out this way. You got to drop and swap to figure that out. Okay, so that's what we've got for sentence versus chemical equations. Don't forget to go backwards, review if you need to. Make sure you've got good notes on this. And I will see you in the next video.